Hey guys, welcome to a kinematics question, and this is going to be my last kinematics video unless you guys have any specific questions you want me to answer. And because of that, I'm going to start a new series where I make my last video on every topic a challenge video. And this is a pretty challenging kinematics question. And this question is, what distance does a projectile travel when we know the initial velocity of the projectile, we know the angle that the projectile is being launched at, and we know that it's being launched on some ramp. And we know the angle of that ramp as well. And for the purposes of this question, we can assume that the ball or the projectile lands on the ramp as well. Okay, so try to pause this video and solve this challenge question for yourself, and then come back when you're finished. Alright, so let's separate all of our information into the components. And why we want to do this is because we want to be able to stretch this information into as many equations as possible. And because in kinematics everything is conserved within its components, right? The horizontal velocity of something doesn't change if there's a vertical acceleration and vice versa. We can get the most out of our information by separating it into components and putting it into variables. Not into variables, but into equations. Alright, so let's start. So let's start with this velocity. Well, we have some velocity, and we know the angle, 25 degrees, that it's being launched at with respect to the horizontal. So, we know that this vertical component of the velocity is going to be the velocity sine 25, and this horizontal component of the velocity is going to be the velocity cosine 25. Okay, but why can I just assume that this is velocity cosine 25 even though it's on a ramp? Well, that's because our angle does not really relate to the ramp. We're given the angle with respect to the horizontal. I can draw whatever ramp I want, and this angle is still going to stay the same because with respect to the horizontal. So we can safely use it to find the vertical and the horizontal velocities. Okay, so let's write those down. So v0y equals v sine 25, and v0x equals v cosine 25. Alright, so now let's separate the distance that the projectile travels into its horizontal and its vertical components, and those are just going to be the vertical displacement change in y and the horizontal displacement change in x. So let me draw out the question. So this is the ramp, and this is the ground, and this is the angle that it makes, 20 degrees. And we have some projectile which travels in some parabolic motion. Alright, so we know that this line right here is going to be the change in x. So the horizontal distance between the beginning and the end. And if I go straight down into the end, this vertical displacement is going to be the change in y. And I don't really care that it went upwards and downwards here because displacement only cares about where you started and where you ended. It doesn't care about the path you took. Alright, so we know that, another thing we know is that this beginning point and this ending point, the distance between them is the distance that the projectile traveled, which is what we're trying to find. Alright, so how can we use this distance to find this change in x and this change in y? Well, because change in x is parallel to the ground, these two angles make up alternate angles. And because they're parallel to one another, they're going to be the exact same value. And you can also do some right triangle geometry to prove that for yourself. Alright, so now that we have this 20 degrees right here, it's the same value as this, we know that d cosine is 20 degrees is going to be equal to the adjacent side, or change in x, and d sine of 20 degrees is going to be equal to the opposite side, or change in y. Alright, so change in y equals d sine 20, and change in x equals d cosine 20. And let's also write that the acceleration, as always with these questions, is 9.8 meters per second squared downwards. Alright, so we have a lot of information, but we don't have quite enough to just plug and chug into one equation. So we have to separate our information into two equations with two variables, and we have to make sure that one of these variables is the distance, because that's what the question's asking us. That's what we're trying to solve. So let's start by separating it into the horizontal components. So we have that change in x equals v0xt plus 1 over 2 at squared. And you might be asking, well, why do I always separate it into this equation? What about this other equation that deals with the speeds? This equation. V final squared equals V initial squared plus 2as. And because it's horizontal, I wrote x here. Well, this equation is fine and dandy, but keep in mind that it gives us the one variable that we need, this distance, and also this V final in the horizontal direction. And when I go to use this equation's twin, this V final y squared equals V0 y squared plus 2ay, I have this other variable, V final in the vertical direction. So I'm going to have our distance variable, but also two other variables. And that's going to be three variables in two equations, and that's not solvable. So it's always useful to use this equation because it has time, and time is going to be same in both variables. But V final x and V final y are not the same at all. Alright, let's continue. So let's say change in y equals V0 yt plus 1 over 2 at squared. Okay, let's see what's our next step. So we have this time in both of these equations, but we don't want it in the end because we only want this distance. So let's try to isolate for time in one of these equations and plug it into the other one. And keep in mind that these equations are no good. We're not going to use them because they give us too many variables. Alright, so because this acceleration is in the horizontal direction, and it's going to be equal to 0, I can just cancel it out. And because of that, this equation is so simple, I'm going to isolate for time in this equation and plug it into the more complicated one. Alright, so let's do that, and I'm going to start putting in this d cosine 20 for change in x, and v cosine 25 for the velocity in the horizontal direction. Alright, so change in x, which I just said is v cosine 20 over v0x, which I said is v cosine 25 equals time. Alright, well that was pretty simple. So let's plug this time into that equation. So let's start. So change in y equals d sine 20, and that equals v0y, which is v sine 25, times time, which we just isolated for in this equation. I'll put it in parentheses so it's easier to see, which is d cosine 20 over v cosine 25 plus 1 over 2 times a, which keep in mind is negative 9.8 because this velocity is upwards and I wrote it as positive, so a has to be negative, minus 9.8 times t squared, and it's this whole quantity squared. So write it in parentheses, d cosine 20 over v cosine 25 squared. And now we have one equation with only one variable. I wrote this as v to save space, but keep in mind, this, we know what it is, it's just a number, it's 100 meters per second. And we can put this into our calculator and get an answer. But when I put this into my calculator, the wrong answer comes out, which means I've made a mistake somewhere along the way. So, can you try to look at all of my work and find what mistake I've made? You can pause the video and come back when you find the mistake. Alright, so as I said for this acceleration is downwards and I wrote it as negative. But this change in y, keep in mind this d sine 20 is just what I wrote for change in y, right? That is also downwards because the ball is going to end below where it started. So this must also be negative. And now that I've done that, and all of our positive velocities and distances are positive, and our negative velocities and distances are negative, I can plug this in and I can get the right answer, which is 1,481 meters. Okay? Well, I hope you found this challenge kinematics question challenging and you enjoyed my explanation of it. And thank you for watching the video.